Hello and welcome to this look at connecting solubility to the pH of a saturated solution. It's a work to exam question using benzoic acid as an example. So the question starts off looking fairly straightforward. It tells you the formula for benzoic acid and one of its uses. That just sets a bit of context really, the fact it's used for preserving fruit juices. It gives you the acid dissociation constant at 25 degrees C. It then tells you the solubility of benzoic acid is 3.40 grams per decimeter cubed. This is an unusual representation of concentration. Normally we represent concentration as moles per decimeter cubed. Now the trick here is to realize that what they mean by solubility is concentration. They're the same thing really. So let's have a look at the sentence and what it says elsewhere. It says calculate the pH of a saturated solution of benzoic acid in water at 25 degrees C, and like we've already said, it's provided a value in a slightly unusual way, so you've got to do a bit of converting. So firstly, saturated solution means the maximum amount of benzoic acid has been dissolved in that quantity of water. So if we're talking about 3.40 grams per decimeter cubed, then that means that that is the quantity of benzoic acid that's been dissolved in 1 decimeter cubed, and you can't dissolve any more than 3.40 grams. So that means the solubility value can be mathematically applied. And like I said a moment ago, solubility can be taken to mean the same as concentration. So the way that you convert grams per decimeter cubed into moles per decimeter cubed is simply to divide it by the molar mass. So the molar mass of benzoic acid is obviously 122 grams per mole. We'll come back to that in a moment. So I got 122 by multiplying the number of carbons. So 6 carbons by 12 plus 5 times 1, another carbon which is 12, 2 oxygens is 32, and a hydrogen is 1. So adding all that up gives you 122. So because it's a weak acid, it tells you this up in the question, that means that there's going to be a Ka expression required somewhere. So the first step is to write that out. So I put my two dissociation products in the numerator and my original undissociated weak acid, my benzoic acid, in the denominator. And then as normal, you'd arrange to make the H plus concentration term the subject, like that. But now what we need to do is actually isolate what this is. The only clue we have really is this value. So what I've done is I've divided my 3.40, which goes up here, by 122, which goes here, to get my concentration in moles per decimeter cubed. And I've put ... there because I've kept the calculator value. So putting those numbers through my calculator, that gives me this long number, and I'm going to use that long number in the pH expression. And that gives me another long number, 2.87770182. But remember that pH values always need to be expressed to 2 decimal places. Hence we write 2.88. Okay, I hope this has been a useful look at a slightly applied way of coming at concentration. Until next time, thanks for listening and see you soon.